This is SpaceTime, Series 26, Episode 3. Coming up on SpaceTime, the most exotic type of neutron star ever seen, Japan's lunar lander on its way to the moon, and planet Earth reaches perihelion. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified an unusually small neutron star, which could be the first ever confirmed detection of a strange star. The findings, reported in the journal Nature Astronomy, suggest that this star, catalogued as HESS J1731-347, has less mass than our Sun, a feat no other neutron star ever observed has ever achieved before. Although only a dozen or so kilometres wide, neutron stars are the densest objects in the universe other than black holes. In fact, just 1 teaspoon of neutron star material would weigh over 4 billion tonnes. Neutron stars are the super-dense cores of progenitor stars between 8 and 20 times more massive than the Sun. When these huge stars run out of core hydrogen for nuclear fusion, the process which makes stars shine, hydrostatic equilibrium, that is the balancing act between gravity crushing the star inwards under its own tremendous weight and the immense outwards force generated by nuclear fusion, suddenly ceases and gravity wins. This causes the entire mass of the star to instantaneously collapse in on itself, immediately crushing down into its core. That triggers a massive explosion known as a core collapse or Type II supernova, an event bright enough to outshine an entire galaxy. While most of the star is destroyed and blown away in this massive blast, a super-dense core remains. And if this remnant core is more than what we call the Chandrasekhar limit, that's 1.44 times the mass of our Sun, the stellar collapse forces the positively charged protons and negatively charged electrons in the core to overcome a force called electron degeneracy, which would normally keep the two apart. Instead, they're forced together, creating neutrons, hence the star's name. So, to find a neutron star that appears to be smaller than this 1.44 solar mass limit raises some interesting questions, and the possibility that this wasn't made like other neutron stars. Protons and neutrons are actually composed of smaller particles called quarks. There are 6 types or flavors of quarks: up, down, charm, strange, top and bottom. Protons are composed of 2 up quarks and a down quark, while a neutron is made up of 1 up quark and 2 down quarks. For years, astronomers have hypothesized about even more exotic types of neutron stars, such as quark stars, which would be composed of free-floating quarks rather than those bound up in neutrons. Another subset would be strange stars, in which half the quarks will be made up of strange quarks due to the breakdown of subatomic particles rather than up or down quarks. To find out what HESS J1731-347 really is, astronomers with the Institute of Astronomy and Astrophysics in Germany used a new approach to measure its distance. The star is located at the heart of the supernova remnant it created. Supernova remnants are spectacular clouds of gas, dust and debris produced during the supernova explosion. They used data from the European Space Agency's Gaia spacecraft mapping survey, which identified a regular star 10,437 light-years away, which is illuminating part of the supernova remnant around HESS J1731-347. So, this means that HESS J1731-347 is far closer than the 16,960 to 26,745 light-years previously thought. And that's allowed for a far more accurate measurement of its size, which suggests that it's just 10.4 kilometres wide and only 0.77 solar masses, far too small to be a traditional neutron star. The authors suggest that it's not just exotic, but it may actually qualify as a strange star. If confirmed by further research, HESS J1731-347 will be the first confirmed strange star ever discovered, and consequently the theory behind its existence will be confirmed. And that would force a rewrite of the science textbooks. On the other hand, if it's found not to be a strange star, then existing hypotheses about neutron stars will need to be re-examined. Either way, it means some interesting times ahead for stellar evolutionary astronomers. This is SpaceTime. Still to come, Japan's lunar lander on its way to the moon, and SpaceX wraps up a busy year. All that and more still to come on SpaceTime. A Japanese spacecraft carrying a small lunar rover is on its way to the moon following a spectacular nighttime launch aboard a Falcon 9 rocket from the Cape Canaveral Space Force base in Florida. The mission for Japanese startup company iSpace is the first in the Hakuto-R or White Rabbit program, which could see a series of follow-up missions.
As for weather, we are still currently green and the range is ready to support liftoff. The clamp arms are now fully open. Now at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both first stage and second stage should finish loading propellant about a minute apart from each other.
Stage 1 LOX load complete.
Great timing. There's that call out that LOX load is now complete on the first stage. At T-minus 60 seconds, Falcon 9 will be in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. And just inside T-minus 2 seconds is when we light the Merlin 1D engines for liftoff. The iSpace Mission 1 payload continues to be healthy, and the Falcon 9 team is tracking no issues on the vehicle, and the range is still green for launch.
Stage 2 LOX load is complete.
Great news. Liquid oxygen loading completing on the second stage concludes propellant loading of Falcon 9.
Ground gas closeouts has started.
Falcon 9 is in startup.
There it is. The vehicle is also now pressurizing for launch, and now we are just waiting for the final call from the launch director.
Falcon 9, iSpace. Go for launch.
Great news. All systems are go for launch of Falcon 9 with iSpace Mission 1.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying the iSpace Series 1 lunar lander. During ascent, we tilt the engines, which we call gimbaling, and that turns the rocket horizontally. And that's what we call a gravity turn. We are still
Telemetry is nominal.
We are still going up, but we are also heading horizontally away from the launch pad. The rocket typically needs to go 17,000.
Vehicle supersonic.
The rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get
Max
into
Q.
orbit. And we just heard a call out for max Q. That is maximum dynamic pressure. This is the largest structural load that the vehicle sees on ascent. Now that we're past the period of max Q, or maximum dynamic pressure,
Engine chill.
we do have 5 events coming up in quick succession. That'll be MECO, stage separation, stage 1 flip, SES1, and then the boost back burn on the first stage will begin. Again, MECO is where all 9 of those engines, those will shut down. That helps slow the stage down in preparation for stage separation. Then the first stage will do a flip in order to make its way back to its landing zone today on land, followed by SES1 or second stage engine start 1 on the second stage. That's where the MVAC engine will ignite. And then the boost back burn will also begin on the first stage.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
We just had MECO stage separation, the stage 1 flipping, SES1, that's the MVAC engine igniting. Stage 1 is currently in its boost back burn.
Bearing separation confirmed.
The fairing halves have deployed from the second stage as well. These fairing halves have completed their 4th and 5th flight and will be recovered when they return back down to Earth on our recovery vessel, Bob.
Stage 1 boost back shutdown.
The engine has shut down on the first stage. That concludes the boost back burn for stage 1. We are in the first of 2 planned MVAC burns before payload deployment. At T plus 6 minutes and 33 seconds, the first stage's entry burn. That burn will last about 20 seconds. Now, the entry burn is where we relight 3 M1D engines, starting with the center E9 engine, then followed shortly afterwards by the E1 and E5 engines. Now, that slows the vehicle down as it passes back into the Earth's atmosphere. Now, we need to slow the stage down in order to reduce re-entry forces, and that helps us with recovery and reuse of the first stage. Now, reusability is key to lowering the cost.
Vehicles on nominal trajectory.
Reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. During that entry burn, Falcon 9 is decelerating by firing its Merlin engines, and we are still moving rapidly. This causes the vehicle to fly through Merlin's exhaust gases, which we also call the rocket's plume, and this deposits a layer of soot on the vehicle's surface. Now, that soot comes from the carbon-based fuel that Falcon 9 uses.
Stage 1, entry burn startup.
This burn lasts about 20 seconds.
Stage 1, entry burn shut down.
Stage 1 FTS is saved.
Next up, in just about 30 seconds, will be the landing burn for the first stage. That's a single engine burn, the center E9 engine. Each engine is optimized for sea level.
Startup terminal guidance.
And it has about 190,000 pounds of thrust. So that single engine is just enough thrust to enable the first stage vehicle to touch down on its landing zone. Today will be
Stage 1 transonic.
It will be landing zone 2 or LZ2 that we will be attempting to land on today. And just shortly after the landing burn begins,
Stage 1 landing burn.
vehicle landing burn has begun. We also heard the shutdown of the second stage engine, but let's watch as Falcon 9 touches down for landing with this incredible view here.
Nominal orbit insertion.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
Falcon 9 has touched down on landing zone 2. That is our 155th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy. Now, we also had SECO 1, or second stage engine cutoff 1, and that is of that MVAC engine that you can see there shut down. But the mission is not over just yet. The second stage is now embarking on its first coast phase. After the coast phase, we will light that MVAC engine for a second time at T plus 40 minutes.
Hakutu-R is slated to touch down on the lunar near side in April in what will be the Year of the Rabbit in the Japanese zodiac. The 2.5-metre wide spacecraft includes a 10-kilogram lunar rover built by the United Arab Emirates. Hakutu-R was one of 5 finalists in Google's Lunar X Prize competition, calling on private companies and organisations to land a vehicle on the moon by 2018. No one managed to achieve that in the time frame, but another finalist, Israeli organisation SpaceIL, did manage to reach the moon with their own spacecraft the following year. However, the mission didn't end well. A communications issue suddenly developed during the very final moments of the crucial landing phase, long enough for the spacecraft's braking process to fail, resulting in the lander crashing onto the surface. SpaceIL are now building another lunar mission. This one will include an orbiter and 2 lunar landers, with a possible launch date in 2025. As well as the United Arab Emirates rover, the iSpace Hakutu-R lunar lander is also carrying 2 robots developed by the Japan Aerospace Exploration Agency, JAXA. Hakutu-R and its payloads were deployed from the upper stage of the Falcon 9 rocket 47 minutes after liftoff.
The next major milestone coming up on today's mission is the deployment of the iSpace Series 1 lunar lander from Falcon 9's second stage.
iSpace M1 payload deploy confirmed.
The iSpace Series 1 lunar lander is now on its way towards the moon.
Hakutu-R is taking a long, looping, fuel-efficient trek to the moon. The lander is expected to touch down inside Atlas Crater in April, on the southeastern edge of the moon's Mare Majoris, the Sea of Cold. If successful, at least 2 more missions will follow, one in 2024 and another the following year as part of NASA's Commercial Lunar Payload Services program. It's using private landers to get agency science gear to the moon. After 2025, iSpace plans on undertaking at least 2 lunar missions annually, carrying a variety of payloads. Also aboard for the flight was NASA's Lunar Flashlight CubeSat spacecraft. Lunar Flashlight will search for signs of water ice in shadowed craters near the moon's south pole, the planned site for a future manned Artemis lunar base. Lunar Flashlight's principal investigator Barbara Cohen from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the mission is literally bringing a flashlight to the moon, shining lasers into these dark craters, looking for definitive signs of water ice covering the upper layer of lunar regolith.
We do have a ride share on today's mission. Lunar Flashlight will deploy around T plus 53 minutes. We are now coming up on the final milestone for today's launch, the deployment of Lunar Flashlight. Managed by the Jet Propulsion Laboratory, operated by Georgia Tech, and integrated by Maverick Space Systems, Lunar Flashlight will be finding and mapping water on the moon, which will help enable humans to permanently work and live on the surface of the moon. Using a new green propulsion technology and 4 compact lasers, Lunar Flashlight will peer into permanently shadowed craters and areas of the moon that never see sunlight.
Lunar flashlight separation confirmed.
And we just heard that call out that we did have deployment of the Lunar Flashlight, confirmation of payload deploy. So Lunar Flashlight is now on its journey to find water at the south pole of the moon.
This is Space Time. Still to come, SpaceX wraps up its busiest year ever. And in January Skywatch, the Earth reaches perihelion, a look at Sirius, the brightest star in the night sky, and the Quadrantids Meteor Shower are among the highlights of the January night skies. December was a busy month for SpaceX. Saw the Hawthorn California-based company set a new record with 61 launches for the year, while at the same time increasing its overall launch numbers to beyond 200 flights. Just 3 days before the launch of Japan's Hakuto-R mission to the moon, which we spoke about earlier, SpaceX launched 40 internet broadband satellites for rival company OneWeb. OneWeb's building a 648 satellite constellation in low Earth orbit. The 150-gram satellites were originally slated for launch aboard Russian Soyuz rockets. But the European Union's boycott following Moscow's invasion of Ukraine saw a switch to a mixture of American SpaceX and Indian rocket launches instead. Its latest launch from Pad 39A at the Kennedy Space Center in Florida was the 4th launch for the same Falcon 9 core stage, which then returned safely to Cape Canaveral, touching back down on landing zone 1. The SpaceX launch will expand OneWeb's constellation to just over 500 satellites. Mind you, that's still well behind SpaceX's Starlink, which now has a constellation of 3,666 spacecraft in orbit. Just over a week later, SpaceX launched the first pair of Boeing O3BM powered telecommunications satellites for Luxembourg-based company SES. The new spacecraft use a software-defined payload. This is allowing them to provide more than 5,000 steerable spot beams per satellite, providing from as few as 50 megabits per second up to multiple gigabits per second per customer. After liftoff from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida, the Falcon 9's core stage returned safely to Earth, landing aboard a drone ship pre-positioned downrange in the North Atlantic Ocean. This was the 8th launch and landing for the same booster. Meanwhile, on the same day on the other side of the country, SpaceX launched NASA's Surface, Water and Ocean Topography, or SWOT mission from the Vandenberg Space Force Base in California. SWOT, which we covered last week, will conduct the first global survey of Earth's surface water, providing the most detailed understanding yet of the ocean's role in climate change and freshwater management. The mission was the 6th launch and landing for the same Falcon 9 first stage booster. The following day saw another Falcon 9 blast off from Pad 39A at the Kennedy Space Center, this one carrying another 54 Starlink broadband internet satellites into orbit. The mission's Falcon 9 core stage was undertaking its 15th flight. After main engine cutoff, or MECO, and stage separation, the booster returned to Earth, landing safely on a drone ship pre-positioned downrange in the North Atlantic Ocean. And finally, on December the 28th, SpaceX launched another 54 Starlink satellites into low Earth orbit from the adjacent Pad 40 at Cape Canaveral. This flight was the 11th launch and landing of the same Falcon 9 core stage booster. And it brought to 61 the total number of launches and landings this year by SpaceX, and 201 the total number of orbital flights now undertaken by SpaceX. This is Space Time. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door. That's because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to the ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. Of course, from an astronomical point of view, January marks Earth's closest orbital position to the Sun, perihelion, which occurs about 2 weeks after the December solstice. Planets, including the Earth, don't orbit the Sun in perfect circles, but rather in ever-changing elliptical orbits. The shape of these orbits vary due to gravitational influences from other planetary objects. And in Earth's case, that especially includes the Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. This difference is known as eccentricity, and the nearest point in Earth's orbit around the Sun is called perihelion. This year's perihelion took place yesterday, Thursday, January the 5th at 3:17 a.m. Australian Eastern Daylight Time, when the Earth was exactly 147,098,925 kilometres from the Sun. That's 11:17 in the morning of Wednesday, January the 4th, US Eastern Standard Time, and 16:17 in the afternoon of January the 4th, Greenwich Mean Time. Around 6 months later, and about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, a location known as aphelion. Okay, let's start our tour of the January night sky by looking to the northeast, right next to the constellation Orion, where you'll see the brightest star in the night sky, the dog star Sirius. So called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light years, it's also intrinsically bright, and almost twice as bright as the second brightest star in the night skies, Canopus. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the 5th closest star to the Sun, and it's gradually moving closer to the solar system, so it'll steadily increase in brightness over the next 60,000 years, after which time it will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the spectral classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarfs we talked about before, which are about 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Brown dwarfs don't have enough mass to build up the sorts of temperatures and pressures in their cores needed to trigger the nuclear fusion process which makes stars like our Sun shine. Sirius A has at least twice the mass of the Sun and is about 25 times more luminous. The Sirius binary system is between 200 and 300 million years old, quite young by astronomical standards, and it originally consisted of 2 bright spectral type A white stars. The more massive of these 2 stars, Sirius B, consumed its resources and became a red giant before shedding off its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. White dwarfs are stellar corpses of sun-like stars. Stars shine by fusing the hydrogen in their core into helium. When these stars run out of hydrogen, hydrostatic equilibrium, that is the balancing act between the outwards push of nuclear energy and the inwards pull of gravity, ceases, and gravity wins, causing the star's core to dramatically contract and compress under its own enormous mass. As the star contracts, regions around the stellar core which still contain hydrogen move closer to where the core used to be, and therefore the region where pressures and temperatures allow hydrogen fusion to take place. This triggers hydrogen burning in a shell around the core, causing the star's outer layers to dramatically expand. And being further away from the core, the star's photosphere, that is its visible surface, is cooler and so looks redder. The star, now called a red giant, experiences a massive increase in stellar wind production as more and more material flows out from its gaseous envelope. Meanwhile, the increase in pressure and temperature caused by the core's contraction eventually triggers a helium flash, fusing the core helium into carbon and oxygen. While high-mass stars will fuse progressively heavier and heavier elements in their cores, low-mass stars, such as the Sun, don't contain enough mass to fuse carbon and oxygen into heavier elements, and so the fusion process ends. Eventually, the star's outer gaseous envelope drifts away as a spectacular planetary nebula. What's left behind is a super-dense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool down over the eons of time. Our Sun will become a white dwarf in about 7 billion years from now. 5,000 years ago, the ancient Egyptians looked at Sirius and they saw it as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Anubis was later replaced in Egyptian mythology by Osiris as the lord of the underworld, and Sirius became the goddess Isis. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295 and a quarter nights, followed by 70 nights of absence. And this allowed them to determine that a year was 365 and a quarter days long. Their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. Helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. It's been claimed that the Dogon people in Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also claimed that these legends were handed to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. However, a report in the journal Current Anthropology raised serious doubts about whether the stars referred to by the Dogon people were in fact Sirius A and its white dwarf companion. That's because senior Dogon claim the story actually refers to a different grouping of stars. Also, other researchers have pointed out that the Dogon could have heard about the discovery of Sirius's companion and then simply incorporated it into their mythology in 1893 when a French expedition arrived in Central West Africa to observe an April 16 total eclipse and were overheard discussing the discovery. Looking due north just above the horizon this time of year, and you'll see the bright yellowish star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen supplies, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller but hotter subgiant, about 73 times as luminous and almost 9 times the radius of the Sun, and it's in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the first pair. They consist of two faint, small, relatively cool spectral type M main sequence red dwarf stars. The two red dwarfs have been designated Capella H and Capella L. Now, almost directly overhead this time of year, a position in the sky known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Located some 313 light-years away in the constellation Carina the Keel, Canopus looks incredibly bright because it is huge. It's a giant spectral type A white star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of the Sun. Canopus is another bright X-ray source, also most likely produced by its corona, magnetically heated to several million Kelvin. The temperature is also likely to be stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star in our night sky closer than Canopus is more luminous than it, and it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter in our night sky than Canopus, and as we mentioned earlier, that'll remain the case for another 210,000 years. But in 480,000 years from now, Canopus will once again be the brightest star in the night sky, and it will remain so for a period of about 510,000 years. In Greek mythology, Canopus was a helmsman and the navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port of Alexandria in Egypt, and so a star which was visible on the horizon was named in his honour. Now, as we said, it's the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Pappus. Canopus forms part of the stellar association or asterism known as the False Cross, which straddles the constellations Carina and Vela the sails and is often confused with the real Southern Cross or Crux. Combined, Carina, Vela and Pappus used to form the constellation Argo Navis, representing the ship Argo skimming along the river of the Milky Way. But modern-day astronomers consider this constellation simply too big. That's because it was something like 28% bigger than the next largest constellation and had more than 160 easily visible stars. And so, in 1755, it was decided to divide Argo Navis into 3 smaller constellations, Carina, Vela and Pappus. This time of the year, the Southern Cross is upside down, low down in the southern skies during the early evening. For our listeners north of, say, Brisbane, it'll most likely be hidden by trees and buildings on the horizon during the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left side. One of the best things about living in the southern hemisphere is that most of the brightest stars in the night sky are visible during January nights. Sirius the dog star is the brightest, followed by Canopus the navigation star. Third brightest is Alpha Centauri, the furthest of the 2 pointer stars pointing to the Southern Cross and the nearest star system to the Sun. The 4th and 5th brightest stars, Arcturus and Vega, aren't visible in the southern hemisphere during January. But the 6th brightest, Capella, is visible just above the northern horizon. And the 7th, Rigel, marks Orion's knee. Next, in 8th place, is Procyon the little dog. And 9th is Achernar, at the end of the river Eridanus. Finally, there's Betelgeuse, Orion's shoulder, the 10th brightest star in the night sky. So, that's 8 of the 10 brightest stars in the night sky, all visible at once on a warm summer's evening in the southern hemisphere. January also plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate out from a recognizable constellation, like Leo's Leonids or Gemini's Geminids or Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Muralis constellation. In the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that means more than 30 other historical constellations didn't make the cut. The Quadrans Muralis area of the sky falls within the boundaries of the official constellation Bootes. The radiant point of the shower is near the Big Dipper, between the end of the handle and the quadrilateral of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 8 meteors per hour. They're best seen from the northern hemisphere, and unlike other meteor showers which tend to peak for at least a day or two, the Quadrantids only peak for a couple of hours. While most meteor showers are produced by the Earth passing through debris trails left behind by comets, the Quadrantids are one of only 2 meteor showers known to be produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to be the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a near-Earth asteroid telescopic survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December and are caused by debris left behind by the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now to continue the rest of our tour through the January night skies.
G'day, Stuart. It's summertime where I am, and when it's summertime wherever you are, it's usually nice weather and really conducive sort of weather for stargazing, sunny days and clear skies, that sort of thing. Being summer, the hours of daylight are longer and the nighttime hours are shorter. So if you're a bit of a stargazer, you have fewer hours to enjoy the stars and planets. But look, you can't have everything. It's probably better to have the good weather than to have longer nights of bad weather. So let's take what we've got. We'll begin with the evening sky as we can see it from the southern hemisphere. At this time of the year, we find the Southern Cross is more or less upside down, low down on the southern horizon for those at sort of middle latitudes down south. So the Southern Cross upside down, right down on the horizon. If you're a little bit further north, Southern Cross is below the horizon for you. If you're further down south, then the Southern Cross will be a little bit above the horizon. Just depends on where you are. But as the night goes on and as the Earth rotates, the cross will get higher and higher, and it'll end up lying on its sort of left-hand side down towards south-southeast by about midnight or so. So you should be able to see it before you get to bed. Taking the sky as a whole, we see that the Milky Way is stretching all the way across the sky from the south to the north, and it has star fields containing some of the best constellations and some of the best deep sky objects. So starting down in the south of that, we have the aforementioned Southern Cross, or Crux as it is formerly known. Then as we go along the Milky Way, we get to Carina and Vela and Puppis and Canis Major. They're constellations most people aren't familiar with, but to astronomers, they're really beautiful. And then we keep going north along the Milky Way, and we end up with Orion and Gemini and Taurus and some of the more familiar constellations because we're sort of getting in towards the zodiac. Now, all those constellations have some amazing star fields and star clusters and nebulae, all of which can be spotted with just a pair of binoculars, really, although a telescope will bring out more detail. But if all you've got is a pair of binoculars, just sweep along the Milky Way, you'll see some fantastic stuff. So Carina, for instance, has the famous Carina Nebula, a really large nebula. It's quite huge, in fact, and it's a huge conglomeration of nebulosity in stars. You can see that with a pair of binoculars. In the constellation Vela, Vela's interesting, actually, because some of its stars make up a sort of a facsimile or a copycat of the Southern Cross. It's called the false cross, and it's in exactly the same shape and same sort of ratio of the long axis to the short axis, and it looks like a big cross. In fact, when people go out the first time and try and find the Southern Cross, this is what they usually spot, called the false cross, and it's about 2 or 3 times the size of the Southern Cross. So people do get that one confused, but the false cross, nothing really special about it other than the fact that it mimics the Southern Cross. I mentioned Canis Major, the constellation Canis Major. That contains the brightest star in the sky, Sirius. I mentioned Orion, which we've spoken about lots and lots of times. It has the incredible Great Nebula of Orion, plus those 2 bright stars, Rigel and Betelgeuse. And I mentioned Taurus, and Taurus has a fabulous wedge-shaped grouping of stars, which you can just see with the unaided eye. And this is a star cluster called the Hyades. You don't need a telescope, don't even need binoculars. You just see the sort of triangle of a whole group of stars, and it really looks quite striking in the sky. So for us down in the southern hemisphere, it's to our north, and people in the northern hemisphere, it's down towards the south. Also in Taurus is something we've spoken about a number of times on the program. That's a star cluster called the Pleiades, or the Seven Sisters. It's a group of around about 1,000 stars, and it's about 450 light years from Earth. To the naked eye, under dark conditions, dark adapted eyes, most people can see about 6 or 7 stars. That's how it gets its name, Seven Sisters. Some people have claimed to be able to see about 10 or 11 of the stars just with their own eyes. People have got really good eyesight. But binoculars will show you that there are a lot more there. They're too faint to be seen with the unaided eye, but binoculars, and even get a telescope on it, you see lots and lots of stars. Back down in the south, high up in the south, we have 2 galaxies that you can see with the unaided eye, as long as you don't have too much light pollution around, so no street lights or anything like that, and make sure you let your eyes get adapted to the dark for 20 minutes or so. These 2 galaxies are the small and the large Magellanic Clouds, named after the explorer Magellan, and they've been famous and for many, many years and a real draw card to the southern sky. Astronomers really like them because they're not too far away in space terms for galaxies, and they can make out individual stars quite easily these days with the super-duper telescopes that professional astronomers have. The most famous star in the Large Magellanic Cloud was one that blew up back in 1987. It was known as Supernova 1987A. It was a huge stellar explosion, spotted back in 1987, although it had actually happened about 170,000 years before. It just took that long for the light to get to us from that galaxy. So it actually took place a long, long time ago, but we only spotted it in 1987. Now let's turn to just finally to the planets, see what we can see. Last month was the best time to see Mars, because Mars was at what they call opposition, and it was its closest approach to the Earth. But we still had pretty good viewing during January. Because Mars is so small, it's a small planet, as soon as the distance starts to open up between Earth and Mars, Mars will very quickly reduce in apparent size when you look through a telescope. It's getting further away, so it'll seem smaller and smaller, and it's small enough to start with, so it doesn't take long before you can't see any detail anymore on the surface. So if you've got a chance to look through a telescope in the first half of January or so, please do. To the naked eye, Mars just looks like a star. It looks like a sort of a medium brightness star with a sort of an orangey reddish hue. What else? We've got Venus and Jupiter. Now, these can be seen above the western horizon after sunset during January, and both of them are really, really, really bright. But Venus is fairly low down. You still should be able to spot it above the horizon, and Jupiter is much higher up and to the right, not quite as bright as Venus. Mercury is another one. The best time to see Mercury this month, the planet Mercury, the innermost planet, is in the last week of January. It's switching at the moment from our evening sky to the morning sky. So if you go out in the last week of January before dawn, before sunrise, you should be able to spot this brightish sort of star. It looks like a star, quite a tiny pinpoint of a star just above the eastern horizon before sunrise. And that, Stuart, is the sky and the planets for January.
And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.